Hello and welcome back to another math video. Today we will be covering an introduction to quadratic equations, focusing on the key features of those equations, or parabolas, which will be the actual shape you make on the graph. So to start, when we look at the vertex, this represents the minimum or maximum point. So it's the min or max of a graph. So if you had a parabola that looked like that went up, this would be a min, this would be your minimum. If you had a graph that went down, this would be your max. One of the biggest key features of the graph. When we look at the axis of symmetry, this is always given as an x equals equation, and it will just say it's a number. And going back to vertex, remember this is given as a coordinate x, y. So when we talk about the axis of symmetry, this is the vertical line that cuts a parabola perfectly in two. That would allow you to fold it over on itself. For example, in, I don't know, this parabola right here, your axis is going to cut through your vertex. And if that didn't actually help answer the next part, this is the x value of the vertex. So if the vertex, if this is, I don't know, 4, 3, then the axis would be x equals 4. All right, the x value here in the vertex is the same as my x value in the axis of symmetry. When we look at orientation, this is just how does the graph open? So the graph will either open upward or downward. In the examples I gave, this would be upward and this would be downward. This one is pretty intuitive. It's just the way the graph is facing. Is it opening up? Is it going down? Is it a happy U or is it a sad U? When we look at the x-intercepts, this is where the graph touches the x-axis. I don't really like the way I wrote that. So yeah, where the graph touches the x-axis. This is when y is equal to 0. You can have anywhere between 0 and 2 of these. So on a graph, let's say my parabola was something like this. My x-intercepts would be here. Actually, I'm going to do this in a different color. My x-intercepts would be at here and here. I have 2 of them. And these equations would be something, or these coordinate points would be something as x0 and x0, for example. My y value is 0. My y-intercept is a little different. I can only have one of these, and this is where the graph touches the y-axis. Touches the y-axis. And when x equals 0. So on a graph, I don't like how small I'm making this, but I want room. So on a graph, let's say this is my parabola, then my y-axis would be down here. It'd be this point over here. My coordinate would simply be 0, y, or whatever that happens to be. My domain is what my x values are, what they could possibly be going from left to right. So this would be for all parabolas. For all parabolas that exist, this is from negative infinity to infinity. This is my horizontal range, I guess you could say. Or left to right. So when I look at, say, this graph, this works better when I explain it like this. Let's say this is my parabola. These arrows mean it's going to keep going. So when I keep going to the left this way, what am I eventually going to run into on the x-axis? I'm going to eventually run into negative infinity. When I keep going right on the y-axis, what am I going to eventually get to on this side? Positive infinity. The range, it depends on the graph. This is my vertical range. going down to up. Okay, so it's my lowest possible value to my highest possible value on the y-axis, so it's going down, up. Whereas the domain is my lowest possible value on the left to my highest possible value on the right. That I didn't discuss as much because, again, for parabolas, the domain is always negative infinity to positive infinity. The range will differ. In this parabola that I showed here, my range would go from this lowest point all the way to the highest point. And so I'll give another example. If I do something like this, this is my highest point instead. And I would go down to somewhere. So let me ask it like this. This would be my lowest point. So let's just say this is, I don't know, -2. My range would be from -2 in a bracket because I touch it, all the way up to when I go vertically, what am I eventually going to get to when I go up? Positive infinity. So this would be -2 to infinity. This is the opposite. This is my maximum point. This is the highest I can possibly get. So I go from lowest to biggest. I go from smallest to greatest. So on here, if I go down, what am I eventually going to run into? Negative infinity. And so when I write my range, I'm going to say from negative infinity all the way up to, let's call this 3, just as an example. And again, I'm using a bracket because it touches this point. This will make more sense when I actually give examples of this. So, one moment, please. So, to explain this, I will just be using the original parent function, f of x equals x squared, and I'll do an example of what each of these might look like using this as a standard. I know the graph doesn't line up perfectly. For that, I apologize. It's also going to bug me about that these aren't perfectly aligned with the boxes, but that's my OCD brain right there. And I will apologize for all the graphs in advance because they're all probably not going to be the best. So, looking at the vertex, that is either my lowest or my highest point. And so it is this point here, because it goes up from here. This is my lowest point. So my vertex is at 0, 0. And when you find your vertex, specify if it is a maximum or a minimum. This is a minimum. Let's looking at my axis of symmetry. It's always going to be an x equals equation. And in this case, remember, my axis is always equal to my x value in my vertex. So it's x equals 0. To look at this visually, what is the line that I can cut through this and it'll cut the graph perfectly in half? It cuts, I'm going to do this as just a straight line. It's going to cut through this line. It cuts through the x-axis, or it cuts through this middle part of my graph. It cuts through my vertex is what I'm trying to say. And so, moving on, let's look at orientation. Does it open up or does it open down? It opens upwards. It's a happy U. When looking at my x-intercept, where does it touch the x-axis? Where does it touch this horizontal line? It touches it at 0, 0. And again, remember I said that you can have anywhere from 0 to 2 x-intercepts. Looking at the y-intercept, I'm going to have 1. And it just so happens to be the same as my x-intercept. It is also 0, 0. My domain of this graph, remember, if you recall, the domain of all parabolas is negative, I'm not doing that infinity, is negative infinity to infinity. My range is a little different. I'm going from my lowest possible y value to my highest possible y value, whereas domain is going from my lowest possible x to my highest possible x. When looking at range, what's the smallest y value I have? It's down here at 0. So my range is going to go from 0, I do it as a bracket because it touches the point, going all the way up to, where does this graph go if I keep going up? Going up, what am I going to run into? Positive infinity. So I'm going from 0 to infinity. And this would be my little number sum right here. My vertex, axis, orientation, x-intercept, y-intercept, domain, and range. These are the key features of this graph. We're going to do a couple more. Alright, so this will be the graph that we're working with. I apologize again, it's a little quirky, but we'll still be able to pick out the key features of this graph. Starting with the vertex that represents the biggest or the highest or lowest point, the minimum or the maximum. Here, my highest point, or my vertex, is up here, which will be a maximum. It is at 3, 1. And when we find the point, we want to specify, is this a maximum or a minimum? This is a maximum. When looking at our axis of symmetry, it is just the x value in our vertex. It is x equals 3. Keep that in mind. If we notice, this value matches up with this value. That is always the case. Now, looking at orientation, that is the question of, does it open upwards or downwards? Is it a happy U? Is it a sad U? Here, this one opens downwards. It's sad U. Now, when looking at the x-intercepts, that is asking, where is this graph touching this x-axis? Where is y 0? And it touches it at 2 spots. It touches it here, and it touches it here. I'm going to do one more point, actually. I know that's not correct for this graph, but I'm doing it anyway, because I don't feel like redrawing this. I'm so sorry for whoever actually is going to use this. But looking at this graph, these are my 2 x-intercepts. I have an x-intercept at 1, 0 and 5, 0. I can have up to 2 of these. I can have anywhere from 0 to 2, and these are the 2 I have. This is where it touches the x-axis. Looking at the y-intercept, that is where it touches the y-axis. That is where it touches this vertical line. I will only have one of these, and it is at this point here, 0, -1. I know that's not right for parabola, but I'm making it work. So 0, -1 would be my y-intercept. Looking at my domain, this is always -infinity to infinity. Because is there anything stopping me from going to the left all the way over here? No, this arrow keeps going. Is there anything stopping me from going to the right over here? No, this arrow keeps going. My range is a little bit different. Because this represents a maximum, that means that this is my largest point. So I'm going to have to look for what my smallest possible value is. When I keep going down this way, that was terrible. When I keep going down, where am I going to run into? I'm going to eventually get to -infinity. That is the lowest point I can be at. So I'll be at -infinity. What's my highest point? My vertex, my y value, here. It is at +1. This would be my range. Again, the key features of this graph are as follows. We good? We'll do one more. Alright, so this will be the final graph that we'll be going through. Again, I apologize for its poor quality. I'm doing this all by hand. Okay, so let's start with the vertex. This, again, is my highest or my lowest point of my graph. So that'll be this little point here. And it will be found at -1, 2, 3, 4, 5, down 1, 2. So it'll be at -5, -2. And again, when we find what our vertex is, we need to specify, is it a maximum or is it a minimum? So in this case, it is a minimum. When we look at our axis of symmetry, it is x equals -5. Again, it is the x value in our vertex. That is the vertical line that will perfectly cut through our graph. It'll cut it in half and make it symmetrical. That's not really working, but yeah. It'd be this line. We can fold this in half if this was a perfect parabola, but it's hand-drawn, so it's not. I apologize again. So, looking at our orientation, does it open upwards or downwards? Happy parabola or sad parabola? This is a happy one. It opens upwards. When looking at the x-intercepts, these are where this graph touches the x-axis, this horizontal line right here. And it touches it at this coordinate and this coordinate. So at -2, 0 and at 1, 2, 3, 4, 5, 6, 7, 8, -8, 0. I'm going to recount that because it doesn't feel right. Cool. So again, this is where it touches the x-axis. You can have up to 2 of them, and I happen to have 2 here. So let's move on to the y-intercept, which is where this graph touches the y-axis, and it touches it up here. So when I write my y-intercept, it's going to be 0, 1, 2, 3, 4, 5, 6. If we notice, our zeros are opposite. In the x-intercept, it's the y's that are zeros. In the y-intercept, it's where the x is 0. Going over to domain, remember the domain for all parabolas is negative infinity to +infinity. Now looking at the range, that's a bit different. What is the lowest point that we have? Do we have a minimum? Yes, we do. It's down here at our vertex. It is down here at -2. When I go up, what am I eventually going to run into? Infinity. So my range is going to be from 2, negative 2 in brackets, because we touch that point, all the way up to positive infinity. And this is the key features of my parabola, of my quadratic equation. Thank you all for watching. I hope this was helpful. Hope everyone has a good one.